today we will have a look on question banks that we have for physics that Sir Jaswin have prepared for you guys. Okay, so here they have given us two diagrams, right? So they have given us diagram A and diagram B that shows two pieces of plasticine attached to a similar hacksaw blade at the same length, right? So the two plasticine then are set to oscillate. Oscillate means they are moving back and forth in the same position, right? The frequency of oscillation for both plasticine is determined as shown, right? In the diagram A lah, right? Okay, Raja A dan Raja B menunjukkan dua ketul plasticine dilekatkan pada dua bilah gergaji yang sama panjang, right? So kedua-dua plasticine kemudiannya diayunkan, maksudnya digetarkan lah, dia bergetah depan belakang, okay? Frekuensi ayunan bagi kedua-dua plasticine ditentukan sebagaimana ditunjukkan dalam Raja A dan B. Ini adalah Raja A, ini adalah Raja B. Okay, kamu boleh tengok ayunan dia depan dan belakang, right? It's going left and right, correct? It's going left and right up, okay? Back and forth. So they have attached all that. That is the hacksaw blade, and you can see that's the plasticine. Okay, the frequency heard in diagram A is 15 Hertz. Okay, and the frequency hertz in diagram B is 5 Hertz. Okay, frequency yang dicapai pada diagram Raja A adalah 15 Hertz dan yang dicapai pada gambar Raja B adalah 5 Hertz. Okay, teliti teliti dengan gambar. Senang mudah dan faham. Okay, dari sini kita tahu panjang gergaji tidak berubah. Okay, jisim dari sini kita dapat tahu panjang gergaji tidak berubah. Okey, tidak berubah, dia malar. Maksudnya dia tak dapat dikacau lah, dia malar sahaja, di satu bahagian sahaja. Okey, it's not changing. Okey, it's constant. Right? Okey, bila kita turun pada soalan pula, okay, let's look at the questions. The first question says, what is the meaning of frequency? Apa tu frekuensi? Okay, apa maksud frekuensi? Apa tu frekuensi? Frequency means something that's moving, right? Something that's moving back and forth in the same position, in a singular manner lah. For example, a pendulum that's moving back and forth, pendulum bob moving back and forth in the same parallel line, right? Okay, apa maksud frekuensi? Frekuensinya apa tu frekuensi? Maksudnya sesuatu benda yang bergerak ulang-alik pada arah yang sama dalam satu masa lah, right? That's how you write. Okay, that's how we write. Maksudnya, okay, number of oscillation in a second. Okay, in a second, or you can just add number of complete oscillations in a second. Can also say that. Okay, kamu boleh juga bagi tahu, okay, bilangan ayunan dicapai dalam satu saat. Okay, yang dicapai dalam satu saat. Okay, bilangan ayunan yang dicapai dalam satu saat. Right, easy. Now, moving on. Okay, based on diagram A and diagram B, okay, berdasarkan Raja A dan Raja B, okay, compare the mass of two plasticine. Bandingkan jisim kedua-dua plasticine. Kita tahu dalam raja kedua-duanya hanya gergaji, hacksaw blade is not changing. Dia adalah sama, malar, dia tak berubah, panjang dia tak berubah. Tapi kalau kita tengok pada jisim plasticine, kalau kita tengok pada we have look at the mass of plasticine, it changes, it varies, right? It varies because of the hertz and because of the movement, right? So I can say, okay, bila kita tengok di sini, okay, I can say Raja A, jisim plasticine Raja A lebih kecil daripada jisim plasticine pada Raja B. Okay, lebih kecil daripada jisim raja jisim plastisin dalam raja B. Okay, dalam raja B. Okay, why? Sebab apa? Sebab raja B gerak lebih lambat, 5 Hz, 5 Hz sahaja. Raja A gerak lebih laju, 15 Hz. Why I say that? Because the movement, the frequency that's involved, okay, the Hertz that's occurring on diagram B is way slower than the Hertz that's occurring in diagram A, which is 15 to 5. So that's how I compared lah. Okay, begitulah cikgu dapat bandingkan. Right? Okay. Now, in English, how do we write it? It's the same way. Okay, dalam bahasa Inggeris. Okay, as I was saying, in English, how do we write this? In English, we write it in the same way. Okay, mass of plasticine in diagram A. Okay, in diagram A is smaller than mass of plasticine in diagram B. Mass of plasticine in diagram B. Finish. Easy as that. Right? Easy peasy lemon squeezy. Senang saja, mudah saja. Right? Yang seterusnya, dia bagi tahu bandingkan frekuensi ayunan kedua-dua plastisin. Bandingkanlah. Dari mana kita nak bandingkan? Look at the diagram. Okay, kalau kita bandingkan dengan gambar raja di atas yang cikgu bagi tadi, okay, kamu boleh lihat gambar raja A ada 15 Hz, gambar raja B hanya ada 5 Hz sahaja. Okay, so the second question said compare the frequency of oscillation of two plasticine. Okay, how do you compare? You compare the Hertz that's given in the diagram, right? In first diagram, in diagram A, they gave you that the Hertz was 15. In the second diagram, they gave you the Hertz was 5. So you just compare roughly that the Hertz, okay, frequency ayunan, right? Ayunan dalam gambar raja A, dalam gambar raja A lebih besar daripada frekuensi ayunan dalam gambar raja B. Okay, dalam gambar raja B. Senang. Right? Now, how do we write that in English? Okay, bagaimana nak salin bagi dalam bahasa Inggeris? Senang saja. Same thing. Frequency, right? It comes with a Q, frequency of oscillation, right? In diagram A, okay, is higher than in diagram B. Right? That's all. Then in diagram B. Done. Full stop. Okay? Full stop. Okay? I made it in different colors so you can see lah how to answer. Okay? I made it in different colors so you can see how to answer. Moving on, third question. Relate the mass and the frequency of oscillation of the two plasticine. Hubung kaitkan jisim dan frekuensi ayunan bagi kedua-dua plasticine. Maksudnya that we compare the mass and the frequency of A and B, right? Now we have to interrelate mass and frequency. How do they correlate to each other? Okay, bagaimana tadi kita buat bandingan antara gambar raja A dan gambar raja B kan? Okay, begitulah sama juga sekarang ni kita akan buat bandingan antara jisim dan frekuensi. Okay, dua fakta fizik. Ya, so kita boleh kata, okay, kalau jisim dia tinggi, frekuensi dia kurang. Ataupun kita boleh kata kalau GSM dia kurang, frekuensi dia tinggi. So we can say, okay, jika GSM meningkat atau bertambah, okay, apa akan berlaku? Frekuensi akan berkurang. Okay, frekuensi akan berkurang. Okay, akan berkurang. Okay, in English, how do you write this? How do you write this in English? Okay, how do you write this in English? The greater the mass, in English I'll write it in the opposite manner. Okay, the lower the mass, the higher the frequency. Okay, the higher the frequency. Done. Okay, that's how you write it in English. Okay, the concept that involves here obviously is going to be inertia. Okay, inertia. Simple as that. Done. Continuing, next question. What happened to the frequency of oscillation when the length of Hawksaw blade clamp is shorter? Okay, apakah yang akan berlaku kepada frekuensi ayunan apabila panjang bilah gergaji yang diapitkan pendek? Okay, what happens to the frequency of oscillation? Okay, if it's shorter. Okay, if it's shorter. If you have looked at any YouTube videos or any experiments in your schools that you do with pendulum bobs, okay, the longer the string with pendulum bob, the slower it moves. Okay, the shorter it is, the faster it moves. Okay, the shorter it is, the faster it moves. Like when you watch the Conjuring movies, right? When they have the pendulum clock, when they flick it, okay, when they lower the time, when they lower the middle gauge, right, it moves faster, it flicks faster, right? If they increase the gauge, it moves slower, it ticks, talks slower. Okay, kalau kamu tengok dalam movie bahasa movie Hollywood ke, movie Hollywood ke apa ke, kamu akan tengok satu jam dinding atau jam meja yang dia akan ada pendulum based, okay, yang dia akan mempunyai konsep pendulum. Bila kaki dia bergoyang, okay, kaki dia bergoyang, jam akan gerak. Okay, kalau kaki dia goyang laju, jam gerak laju lah, maksudnya itu dikira saat. Kalau kaki dia goyang slow dalam jangka masa yang pendek, okay, maksudnya dia ambil saat. Kalau jangka masa dia panjang, maksudnya dia ambil minit atau jam. Okay, so begitulah. Kalau blade, okay, bilah gergaji itu dipendekkan, bila gergaji dipendekkan, masa atau frekuensi ayunan akan bertambah laju. Okay, if the Hawksaw blade is clamped shorter, right, the time, the frequency will increase. Okay, will increase ataupun meningkat. Okay, ataupun bertambah laju. Done. Simple. Okay, tepat dan padat, itu saja. Cara nak jawab fizik adalah tepat dan padat. Okay, moving on. Last question of this sector. Last question. Okay, time taken for the 20 oscillation of the plasticine is 10 seconds. The clues there, okay, masa yang diambil untuk 20 ayunan lengkap bagi plasticine adalah 10 saat. Okay, hitungkan, calculate the period of oscillation, tempo ayunan, yang kedua frequency of oscillation. Okay, frekuensi ayunan. Kamu kena kira dua bahagian ni saja. Okay, kita tahu period of oscillation, apakah simbol dia? Kalau bagi tahu saja period, okay, apa simbol yang kita tahu? Period sama dengan T besar. So kita kena cari T besar. Kalau kamu tengok buku teks, okay, dia akan ada satu eksperimen yang dia buat menggunakan pendulum atau menggunakan, okay, buku teks, okay, kita ada satu eksperimen yang dia buat dengan menggunakan pendulum ataupun spring balance, right? There are two experiments in textbook where they use two type of experiments. One is using spring balance, another one is using pendulum bob. So you can take both of them. Okay, both uses a single formula. Kedua-duanya menggunakan satu formula asas, iaitu T sama dengan masa bahagi bilangan ayunan. Masa bahagi bilangan ayunan. So kan formula dah ada, plug and play. The concept is plug and play. Cabut dan main. Plug and play lah, plug and count. That's all. So you take a plug. Apa tu T? T tu masa. Right, time. What is N? Apa tu N? Bilangan ayunan. Right, number of oscillation. That's all. So you just plug, you play, time is 10 divided by 20. Ambil 10 bahagi dengan 20, dapatlah sifar perpuluhan 5 saat. You will get 0.5 seconds. Calculator, dapatlah jawapan. Kemudian yang kedua. Yang kedua, kita ada frekuensi ayunan. Right, we have frequency of oscillation. So frequency of oscillation, how to find? Frequency maksudnya F, right? F. Kita tahu hertz. Right, hertz apa kiraan dia? 1 per saat. 1 bahagi saat. Betul, 1 bahagi saat. Begitulah F pun sama. Right, F pun sama. F itu frekuensi, right? So it is equals to hertz, which is 1 bahagi saat. Tapi dalam kiraan ni, saat kita kira dengan T, betul? So 1 bahagi dengan T besar. Habis. So 1 divide by 0.5, we will get, calculator, we will get 2 hertz. Calculator sahaja. We will get 2 hertz. Done. So if you can rewatch some of the parts that if you don't understand, to collect all the memories and to find all the steps. So that's for this chapter. Itu sahaja untuk bahagian ni. So di sini kita belajar cara nak selesaikan soalan inersia dalam peperiksaan fizik. Untuk struktur, untuk bahagian A structure lah. So here we watched how to solve a inertia question in physics paper 2 structure on section A. For more